Up until now, we've been talking about technical aspects of production, the cost of production, and profit-maximizing decisions by firms, and how that leads to a supply curve. It's important to recognize that that's only one side of the market. The other side of the market are consumers who buy the goods that firms produce. We're now going to shift gears and look at those consumers and look at it through the context of consumer choice and demand. This material draws from chapters 4 and 5 of the textbook. Now, one of the things that underlies consumer demand is this notion of utility theory, and in particular, the total utility. Now, as we talked about when we were dealing with choice under risk, utility is really the level of satisfaction that you get from consuming something. In the risk part of the course, it was the utility that you receive from your wealth or your earnings. In the consumer part of the course, utility is really the level of satisfaction that you get from consuming different goods and services. Those goods and services are what we call a consumption bundle, and all that is just different combinations of goods and services that you might choose to consume. A utility function is an algebraic expression that allows us to rank different consumption bundles by the total utility or satisfaction that it provides. In some ways, you can think of a utility function as the consumer equivalent as a total physical product function or a production function. Now, what's important with the utility function is that the utility you receive depends not just on what you consume, but how much you consume. Now, to get across at that, let's think about three different bundles. Let's think about bundle A of goods, bundle B, and bundle C. And let's just suppose, for the sake of argument, that these bundles consist of Timbits and apples. And let's suppose that bundle A has 4 Timbits and 2 apples, bundle B has 3 Timbits and 3 apples, and bundle C has 5 Timbits and 1 apple. Which bundle do you prefer? I think if we ask this question in class, that we'll see that different people will prefer bundle A versus bundle B versus bundle C. And so really what we're getting at here is that all of you have different types of utility functions, and those utility functions reflect your underlying preferences. Those preferences actually are very important, and economists have a lot of respect for not judging what people consume, but trying to understand why people consume what they do. This gets back to a phrase that is in Latin is de gustibus non est disputandum, which essentially says there's no accounting for taste. And the idea here is that economists, we don't judge people because they prefer one bundle over another. What we want to do is focus on what can be said about those tastes to try to understand who might consume what, but we say that without any kind of judgment or subjective evaluation of whether those preferences are good or not good. Now, equivalent to what we saw in producer theory and talking about marginal product, we can also think about marginal utility. And all marginal utility does is measure the change in utility provided by one additional unit of a good or a service. So it's the utility that you get from that last unit that you've consumed. What's important is that it's the last unit consumed of a particular good or a particular service, holding consumption of all other goods and services constant. We can calculate this conceptually by saying marginal utility, which we abbreviate as MU, is equal to the change in utility divided by the change in the quantity of the good that you're evaluating. In class on Monday, we'll actually go through a little experiment where we try to understand how you might go about measuring marginal utility and illustrate how marginal utility can change as you increase your units of consumption. In particular, what we'll hopefully be able to show is that each additional unit consumed will increase your overall utility, but it will increase your utility by a smaller amount. Now, the other thing that's important is that this notion of total utility can decrease. That is to say, you can actually have less utility by consuming more. Think about Thanksgiving meals or Christmas Day meals and eating more than you probably should and how you feel after you've eaten more than you probably should. You might actually think that your utility is lower after you've had that last mouthful than you did when you started the meal. Also important in this is the notion that if total marginal utility or total utility begins to decrease, then your marginal utility can actually be negative. And like production, we also deal with the law of diminishing marginal utility. The idea here is that as the amount of consumed good increases, marginal utility will eventually decrease and possibly become negative. So really what we're getting at when we say that each additional unit consumed increases utility by a smaller amount is a statement about the law of diminishing marginal utility. In particular, that as you consume more, the law of diminishing marginal utility comes into play. Now, we're not going to spend a ton of time talking about utility functions, largely because it's very difficult to measure. But we can conceptualize utility functions using something called an indifference curve. All an indifference curve is the consumer equivalent of an isoquant. Now, what's going on here is a reflection that we don't just consume one good, but we consume many different goods. And so let's consider the bundle of goods we consume when we're talking about utility. And what we'd like to be able to do is to compare different bundles of goods to see which one is preferred. And we can do that through an indifference curve. All these indifference curves do is connect the combinations of two goods that provide equal satisfaction or equal levels of utility. We can draw them for a hypothetical example of using beer and pizza. So for instance, we might actually think of one indifference curve looking like this, where the level of utility is, let's say, 100. Along this line that I'm highlighting with the mouse is different combinations of beer and pizza that give us 100 units of utility. What's also true is that as you go further away from the origin, the level of utility increases. So if I were on an indifference curve that were to the northeast of the one that I've drawn on the screen, I would have a higher level of utility. So just to reiterate a point, different levels of consumption of beer and pizza that fall along that indifference curve have the same level of utility. So for instance, one consumption bundle where I have 1 unit of beer and 3 units of pizza would give me 100 units of utility. But so too would a different consumption bundle where I've got 4 units of beer and 1 unit of pizza. So both of those bundles give me the same level of utility. Which one I'll choose to consume is an issue that is core to consumer demand that we're going to get to in a later lecture. Now, those indifference curves are really important. And they also reflect something that we saw when we talked about production, and that's the marginal rate of substitution. In the context of the consumer's indifference curve, the marginal rate of substitution is simply the rate that the consumer is willing to substitute one good for another while keeping the level of utility fixed. Really what we're doing is talking about the slope of the isoquant in a particular point. Now, what's also important to understand with all of this is that we cannot measure utility directly. We can't even see an indifference curve, let alone try to estimate one statistically. But experiments that have been conducted by economists and also by psychologists have shown that utility theory is consistent with how people behave when they're faced with constrained choices and when they have to choose amongst different bundles of goods. The other thing that's important with indifference curves is that they can take different shapes. I've drawn a general indifference curve that is a curvilinear type of relationship, but we can also have indifference curve that reflects goods that are perfect substitutes and goods that are perfect complements. To put some concrete action on this, let's think of perfect substitutes as maybe bottled water or water from the Nestle plant here in Guelph and tap water. To a lot of people, bottled water and tap water are perfect substitutes. They'll take one versus the other. When those goods are perfect substitutes, their indifference curve is a straight line, as I've drawn here. Now note that that line is downward sloping. With perfect complements, we end up with an indifference curve that looks like this L-shaped curve that I'm highlighting with the mouse. An example of goods where we might have perfect complements are pairs of shoes. So we have a left shoe and a right shoe. We need one shoe to give us a pair of shoes, and we think of those as perfect complements. Now, the indifference curves are really important because they characterize something about the relationship between the level of goods that you're consuming and the amount of utility that you're going to get from it. And those indifference curves in utility is one side of the consumer choice problem. In particular, it's the side that says this is the benefit that you get from consuming these goods. What it doesn't reflect is the cost associated with consuming those different goods and services. And that's where this thing called a budget constraint comes in. And a budget constraint is simply the amount of money that the consumer has available to spend on different goods and services. It's very much like an ISO cost line, but it's treated in a subtly different way. Now, to get at a budget constraint, recognize that total expenditure by a consumer is determined by multiplying the quantity of each good that you buy by that good's price, and then totaling the total value of those purchases. So for instance, we might think of a two-good example of beer and pizza that we illustrated the indifference curve with previously. Our expenditure on beer and pizza is going to be price times pizza times quantity of pizza, plus the price times beer times the quantity of beer that we've drunk. Now let's just suppose for the sake of argument that we had $20 available. What we want to get at with the budget constraint is what are the feasible combinations of pizza and beer that we could buy with our $20. Now for the sake of argument, let's just suppose that a slice of pizza is $4 and a bottle of beer is $2. Well, if I have $20 to spend and I spend all of it on pizza, what I would find is that I could buy up to 5 slices of pizza, but I wouldn't be able to buy any beer. Another combination of pizza and beer that gives me back the $20 that I have to spend is 3 slices of pizza and 4 bottles of beer. If all I consumed was beer, then what I would end up doing is buying 10 bottles of beer and no slices of pizza, and I'd exactly exhaust all of my expenditure. Now, the table that we've shown here isn't very useful and isn't very beneficial in terms of trying to think about how consumers make choices, so let's graph these different combinations. And so what I'm going to do is I'm going to draft the budget constraint on the pizza and beer diagram, where we're going to later put on top of this the the indifference curve associated with the consumer's utility function. If all I consumed was beer, I know that with the given prices and how much money I have to spend, I'd consume 10 units of beer. If all I was going to do was consume pizza, and for the given price of pizza and the amount of money that I have available, I know that I would consume 5 units of pizza. The budget constraint just connects these two dots. And so this green line reflects the different combinations of pizza and beer that I could consume that exactly exhausts the amount of money that I have to spend. So for instance, if I were going to buy 3 units of pizza and 4 units of beer, it would appear at the point that I'm highlighting with my mouse on that on that budget constraint. Now, budget constraints are really important and really useful, and one of the things that's important to understand is how budget constraints change when either the amount of money you have to spend changes or when the prices of the goods change. So what would you think would happen to the budget line if your budget doubled? Well, we could go through the argument with the table that we did before that said, well, let's suppose that all we were going to do is consume beer. If instead of having $20, I now have $40, and beer costs $2 a bottle, and all I'm going to do is consume beer, then what I know is that I'd be able to buy 20 bottles of beer. On the other hand, if all I was going to do was consume pizza, and I have $40 to spend, and pizza costs $4 a slice, then I know that I would buy 10 slices of pizza. Those are extreme points on the budget constraint, and if we connect those different dots, we get a new budget constraint that reflects the fact that the budget is doubled. One of the things I want you to get away from this slide is that as my expenditure increases, or as the amount of money that I have available to spend increases, my budget constraint will shift out to the northeast direction. By the same token, if the budget line, if my budget or how much money I have available to spend falls, then that'll also change the position of the budget line. Let's just suppose for the sake of argument that my budget fell to $12. So I only have $12 when I'm going out for a pizza and beer night. Well, if all I was going to do was consume beer, and beer costs $2 a bottle, I know that I would consume 6 bottles of beer, or up to 6 bottles of beer. If I had $12 and all I was going to do was consume pizza, then I know that I would consume up to 3 units of pizza, or 3 slices of pizza. And again, connecting these two extreme points in the budget constraint illustrates what the budget constraint would look like if I had a smaller amount of money to spend in that night out. And so what's important here, and I'm highlighting this with my mouse, is that as the amount of money I have to spend falls, the budget constraint shifts in. We can also think about what would happen to the budget line if the price of the different goods changed. So for instance, what do you think might happen if the price of beer doubled and I had $20 to spend? Well, this is very much like what we saw would happen to this position of the ISO cost line if the price of an input changed, in particular if the price of an input increased. In this particular case, if the price of beer went from $2 to $4 and all I was going to do was consume beer, then what I would know is that I would consume up to 5 units of beer. And so the point here on this that I'm circling with my mouse would be the new intercept point for the budget constraint along this beer axis, and I would have to redraw my budget constraint like this. And so as the price of a good increases, the budget constraint will pivot down along the axis for the good whose price is increased. If the price of that good decreased, then that budget constraint would pivot up and it would become steeper along the same axis. And that's what I want to illustrate here, is what would happen if the price of beer fell to $1. Well, as I hinted at, the budget constraint is going to change its position. And we could understand how that change would happen by recognizing that if I spent all of my budget on pizza, I'd still consume 5 units of pizza. But if I spent all of my budget on beer, that I would now consume 20 units of beer rather than 10. And so when beer becomes less expensive, I'm able to buy more of it. And what we see is that the budget constraint becomes a steeper line, as I've illustrated here. This is a good place to stop, and we'll pick up with putting the pieces of the indifference curve and the budget constraint together in our next video.